Welcome to EDU World Space.
So for part A here, let's go ahead and answer this. Notice that just before injection number 2, the residual concentration is given by DE to the minus AT. This is given. And this is just by the fact that we're given an injection every T hours due to the fact that injection is given typo there every T hours. Now, before the third, immediately before the third, so let's say just before injection number 3, the residual this time is DE to the minus 2AT. So following this pattern, we see that the residual just before the N plus first injection is just DE minus ANT. Now let's go to the next page and add these up. Sum of residuals. Residual concentrations. So we're still in part A here. Now this is just add these all up. And it turns out here we can see that this is a geometric series. And it's finite. It's a finite geometric series. Now we have a formula for this. We could see that the first term, A1, is DE to the minus AT. We also see that R is just E to the minus AT, the common ratio there. So we're using, this is a finite, let me spell it out over here, finite geometric series, which has a different formula, slightly different formula than the infinite series. One minus E minus AT, and that's our answer for part A. Let's move on to part B. So for part B, we take the limit from part A Now let's go ahead and do some algebra here. So I'll go ahead and divide top and bottom by the same quantity. So also on the denominator, that's A times T down there, over E to the minus AT. Now go ahead and clean that up. Let's do the division. D, 1 minus 1 over E to the ANT over E to the AT minus 1. This is just after doing some simplification. Now go ahead and take that limit. Because as n goes to infinity, this circle part goes to infinity, so that the fraction goes to 0. And go ahead and just simplify this. And we're basically done with part B here. This is our answer for part B. Let's go on to part C. So here we need C to satisfy this. So this is due to the fact that the concentration must remain above or at the critical level C. So this is why we have this inequality over here. Go ahead and solve that for D. So the minimal dosage is just D equals C e to the AT minus 1. And that's our final answer for part C, and that completes the problem.